Okay, hi Riza. Let's get to work on your problem. So, you've got a ball resting on the top of a table. The table is half a meter high. Okay, here's the ground. And it's given a kick off the edge of this ledge, which gives it an initial x velocity. So we'll call that Vx0. It's 2 meters per second. Okay, now there are a series of questions we want to answer. Okay, so how long until the ball hits the ground? Okay. Well, we know the ball is going to start with an initial y velocity of 0 because it's sitting on the table. It's not moving up and down. And we know it's subject to acceleration due to gravity. So we can write that formula as the position at time t is equal to its initial position minus 1/2 gt squared, where g is the acceleration due to gravity. Now, what we're looking for is when the ball hits the ground. So we want to solve for time t given a position y. The ball hits the ground when its height is 0. Okay, so we'll solve for 0. Its initial height is half a meter. Okay, and then we know the rest of this. This is 9.8 meters per second squared. And this is t final squared, where the ball hits the ground. So we can solve for this. I'll drop the units for clarity. That's 1.0 meters divided by 9.8 per second squared equals t final squared. And working that out, that's about the square root of 0.102, which is about 0.319 seconds. Okay, so that's when the ball hits the ground. Now, the second question, what's the distance between the edge of the table and the point where the ball lands? Okay, well, we know that the ball is traveling with a constant x velocity of 2.0 meters per second. And we know the ball stops moving at this t final. So what we can do is use another ballistics equation that you've listed, x naught plus vxt. Now, let's say, and this is some time t. Now, we want x at t final. We know x naught is 0. And then we know it's traveling at 2.0 meters per second. And it's traveling for 0.319 seconds. And so that gives us x final, which equals 0.638 or 639 meters. Now, for the final question, what's the velocity of the ball? Okay, we know its x velocity is constant, and that's 2.0 meters per second. But what's its y velocity? Well, it started from no velocity in the y direction, and it accelerated for 0.319 seconds. So its y velocity is going to be downward, and it's going to be the acceleration due to gravity times t final. This is going to equal minus 9.8 meters per second squared times 0.319 seconds. So let's work that out. That works out to 3.126 meters per second, and that's downwards. Okay, now we want the magnitude of the velocity, so that's just the square root of the sum of the squares. So we add these in what's called quadrature, and we get the square root of 13.773, which is about 3.711 meters per second. Okay, thank you very much, Riza. I hope that helped.